In examples 1 and 2, we want to look at identifying the vertex of a parabola, classify that point, and then identify the domain and range of the function. Identifying a vertex from a parabola, so from the graph of that quadratic function, is again just finding the peak or valley of that curve. So in this case, that vertex would be at the point -2, 3. Since that's the largest function value, since our graph is opening down from there, this is an absolute maximum. And then in part D, we want to identify the domain and range of this function. Since it's a parabola, since we're dealing with quadratic functions, the domain will be -infinity to infinity. If we didn't just know that, we can just look at the graph. There are no breaks. The line could be traced. It's smooth without having to pick up your pencil. So domain would be -infinity to +infinity. And our range would be determined on one end by the y-coordinate of our vertex, so this value of 3. And then we just need to determine whether it's going from -infinity up to 3 or from 3 up to +infinity. In this case, we can see that 3 is that largest function value, and we'll only hit y-coordinates smaller than that. So our range needs to go from -infinity up to +3 with a closed bracket to make sure we're including 3 as part of that range. We have a similar problem in example 2, but now we have a parabola that's opening up. Our vertex occurs at Our vertex occurs at 3, -2. In this case, this vertex would be an absolute minimum, since that's the smallest function value that we'll hit. Our domain will be -infinity to +infinity. And then our range will be restricted by, again, looking at the y-coordinate of that vertex, and then considering whether we're including values below that or above that. In this case, -2 is the smallest value, and we'll continue to hit y values greater than that. So our range will be -2 with a closed bracket to include that value as part of the range, up to +infinity.